Point one, in this lecture video, let's take a look at something called the quotient rules for exponent. All right. So for any real number a, okay, any base to the n power, quotient rule means division. So if I have a base raising to the n power divided by the same base, raising to a different exponent, when the base are the same and the base are dividing, what we're going to do is subtract our exponent. All right, so we always take the top exponent subtracts the bottom exponents. Okay, so again, division between anything is only one term, so this rule only works if we actually dealing with one term only. So let me do it this way. Okay, why do we subtract? So if I got 2 to the fourth over 2 to the third, by this rule, I'm supposed to take the top exponent subtract the bottom, which I will get 2 to the first power, or just 2. And here's the reason why subtraction makes sense. Because 2 to the fourth power means 2 times itself 4 times. 2 to the third power means 2 times itself 3 times. So what's going on here is I got bunch of 2's on top, bunch of 2's in the bottom. So when I see all these 2's, I cannot help myself but to reduce them top and bottom. So the subtraction literally means our top factor and the bottom factor are canceling each other out. So I only get a 2 left, which is 2 to the first power. All right. So the subtraction means we'll cancel the same factor top and bottom. So basically, normally what we say is if I got 4 2 on top being multiplied, divided by 3 of those same 2 in the bottom, then when we cancel them out, which is when we're subtracting them, I should have 1 2 left on top compared to the bottom, because the top has 1 extra 2 left than the bottom. Okay, that's why I got 2. So that's why I only have a 2 on the top, because this 2 is viewed as 2 over 1. So that put the 2 on the numerator. So vice versa, for example, if I ever had a 2 to the third on top over 2 to the fourth in the bottom. So now I got 3 2 on top, 4 2 in the bottom. So when they canceled out, that means I should have only 1 2 left in the bottom, because the bottom has 1 extra 2 than the top. So if I only got 1 2 left on the bottom, what should be left on the top? Remember now, when we're reducing fraction, if everything gets canceled out, they all becomes 1. So 1 times 1 times 1 is 1. Okay? So I have 1 extra 2 in the bottom. That's why my answer is a half. All right? So normally I just quickly say, 3 2 on top, 4 2 in the bottom. When they cancel out, there should be 1 2 left in the bottom. So what's left on top? If all the top get canceled out, there would just be 1 left on top. All right. So this example, base are the same and the base are dividing, we subtract the exponent. So rather than, so what the tutorial will do is saying they will write x to the 9 minus 3, okay, to get x to the 6th power. But if you know you are subtracting them and if you know the answer, we can just quickly go ahead and write down the answer. Okay, 9x on top, 3x in the bottom. When they canceled out, that means there should be 6 of those x's being multiplied on the top. Okay, that's the way how we see it. All right, real quick, I got 6 6's being multiplied up here on the top. 4 of those 6's being multiplied in the bottom. So when they canceled out, top and bottom, okay, base are the same, we subtract the exponents. That should leave me with 2 of those 6's left on top. So 6 times 6 is 6 squared, or we can say 6 squared is 36. So for numerical value, we got to actually evaluate them. All right, let's take a look. This is very important that you see this problem correctly. All right, this exponent 6 is only on top of the y. The y down here, if you don't say the exponent, is automatically assumed to be 1. So numerical value was 10 divided by 2, 5. When we say that 5, that actually put that 5 as on the top, because we can write 5 as 5 over 1. All right, so I got 6y on top being multiplied. I only got 1y in the bottom being multiplied. So when they canceled out, or when we subtract the exponents, I should have 5 extra y the top has 5 extra y being multiplied as compared to the bottom. Okay, so when we subtract the exponent, that becomes y to the 5th. Remember now, if we do it this way, this is very confusing from time to time. When we write y to the 6th, if we write this out, y to the 6th minus y to the 3rd, if we just simply write out the subtraction of the exponent, my answer is y to the 5th, right? So when I write this y to the 5th, what we are saying is this base is automatically to be on the numerator because it's automatically over 1. When I write this y to the 5th, it's automatically over 1. Therefore, you put the y to the 5th as the top. All right? So, tell you what, I'm going to give you a quick example here, okay? I'm going to switch the two variable here. I'm going to have 10 to the y over 2y to the 6th. How about that? So again, numerical part, 10 divided by 2 is 5, so that 5 is going to be on the numerator because it's 5 over 1. All right, I got 1 y on top, 6 of those y in the bottom. So when I cancel them out, the bottom should have 5 extra y being multiplied. Okay, so that automatically put the y to the 5th in the bottom because when we subtract the exponent, or if you just cancel them out, all right, you should have 5 of those y being multiplied down here. That's why I got y to the 5th down here. But 10 over 2 is 5. That 5 is over 1. That put the 5 on the numerator. All righty. So in this lecture video, we'll talk quickly about the quotient rule, which is we have to take the top exponent, subtract the bottom, which is basically saying we are reducing top with the bottom, just like how we normally would have reduced fraction back in module 2. All right, that will conclude this quick lecture video. Thank you for watching.